So I want to solve this triangle, so I'm going to draw my triangle, label it, put in what I have. B is 4, C is 5, and this angle is 40 degrees. Once again, I have two sides and one angle, so it's probably the ambiguous case again. So we're going to set it up as a sine of A over A equals sine of B over B equals, sorry, B is 4, equals sine of C over C. So I'm going to solve this. I have 5 sine of 40 degrees divided by 4 is the sine of C. And if I use the sine inverse, I take the sine inverse of this side here, I find that C is 53.5 degrees. So I want to see if there's a C prime. Well, C prime is 180 minus 53.5, which is 126.5 degrees. Now, 126.5 plus 40 is less than 180, so there are actually two triangles. So if I use this C, my A, which is I add 40 and 53.5 and subtract that from 180, my A is 86.5. And my A prime for my other one, again, 126.5 plus 40, subtract that from 180, and I get 13.5 degrees. Remember, A plus B plus C all have to equal 180, so you can check that. Now I can plug it back in, so I either have sine of 86.5 over A is sine of 40 over 4, and that gives me a little a, if I plug that in, of 66.21. Or I can say that sine of 13.5 over A equals that sine of 40 over 4, and that gives me a little a prime of 1.45. So I have two triangles, one where the angle C is 53.5, A is 86.5, and my missing side is 6.21. And the other one, I have an angle of 126.5 and 13.5, and my missing side is 1.45.